This bellwork says that line M and N are parallel. That's what this means right here. We're going to find the value of x. And first thing I notice between these two angles right here, we got an angle x and this 119-degree angle, is that they are sandwiched between lines M and N, the two parallel lines that were given to us. And we do have this line T, the transversal, going through the two parallel lines. So if we can find that these two are one of the three special angle relationships, then we know that they are also congruent. And we see that they're both on the interior at least. They're both sandwiched between the two parallel lines. They are at different intersections, and they're on opposite sides of the transversal. So these two angles that they've given us, angle X and the 119-degree angle, they are alternate interior angles. Okay? And again, since the two lines are parallel, M and N, that means that these two are congruent, which just means they're the same. All right? Now, for today, this means that we're going to take the two angles. We have angle X and the 119-degree angle, and we're going to set them equal to each other, and that tells us the value of X, 119 degrees. Just today, instead of this being more as straightforward as this one is, right? We just say, well, X is 119 degrees. They're the same. They're going to give us expressions as these two angles. So like this one could be 3x minus 4. And maybe even this one could be 5x plus 2, something like that. And then you'd use our equation solving strategies to solve for x. So that's where we see in the objective, I can make and solve equations from special angle relationships and parallel lines. And remember, those three special angle relationships we're looking for are alternate exterior angles, alternate interior angles, and corresponding angles. We are going to see some relationships that are supplementary where the two angles make a straight line. If we see that, we don't really care if the lines are parallel. But take 15 seconds and copy this down, please. So we've seen this diagram before. We got the special angle relationships of alternate interior angles, alternate exterior angles, and also corresponding angles. If and only if the two lines are parallel, then these three special angle relationships are congruent. And we know already that congruent means that they are the same, okay? So when you see this word congruent, it means they're the same. We remember the symbol for congruent is an equal sign with I call it the Enye symbol above it. We won't see the symbol today, but they're just going to say something like congruent, or perhaps I will. Okay, so let's identify on this diagram, even though we've seen it before, a set of alternate interior angles. Now, when it says interior or exterior, it's talking about the parallel lines, not the transversal. So right here, when it says interior, it's got to be on the inside. In this area, one of these four angles here will be interior. All four of these angles are interior, but what about alternate interior? Well, that means that they're at different intersections or vertices on opposite sides of the transversal, okay? So if I looked at angle 3, which is at the top intersection or vertex, it's on the left side of the transversal. Angle 6 would be its alternate interior angle because it's at the other vertex but on the right side of the transversal, okay? So this angles 3 and 6 would be alternate interior angles, but angles 4 and 5 would as well. So what about alternate exterior angles? Again, exterior is talking about just the vertical or the parallel lines here. So that'd be these two angles up here, 1 and 2, and angles 7 and 8. They're on the outside of the two parallel lines. So that would be angles such as angles 2, and again, that's on the right side of the top vertex on the outside. So angle 7 would be on the left side of the bottom vertex. Two purple angles, angles 2 and 7, are alternate exterior angles. Then corresponding angles, again, they're at different intersections, but they're in the same position of the intersection. So that'd be like angles 1 and 5. Now notice, one is exterior, one's interior. Generally that will happen because corresponding doesn't matter if it's interior or exterior. It just needs to be in the same position. Like angle 1, I'd say is up and to the left of this vertex. Angle 5 at this vertex, up and to the left. See, That's what we mean by same position. So angles 1 and 5 would be congruent because they're corresponding. Angles 2 and 7 would be congruent because they are alternate exterior. And angles 3 and 6 would be congruent because they are alternate interior angles. Those three special angle relationships create congruent angles. So what this does is it allows us to create equations, which is part of our objective today. We need to be able to create and then solve the equation that is made. But we see that if we have one of those three special angle relationships, alternate interior angles, alternate exterior, and corresponding angles, that we can set the two angles equal to each other. Just, again, be aware that these two angles, they're not just going to be regular numbers or just a letter. You're going to see now expressions, math expressions as these angles. For example, angle 1, maybe you'll see something like 3x plus 2. And then maybe angle 2 would be 4x minus 8, something like this. Again, if these two angles were either alternate interior, alternate exterior, or corresponding angles, we would say, I'm going to set these equal to each other and then solve. On the assignment, you will see angles that create a supplementary relationship. It's going to call them linear pairs. In the past, you may have heard these as straight angles. What this means is that if you have, let's say we have the two parallel lines, like, let's pretend like I drew parallel lines right here, okay? So we'll put the arrows there. If I have a transversal going through these, I really don't care if the lines are parallel, okay, which I talked about during the objective. If I look at this green angle here, and then this orange one here, see, I don't really care about this other line because neither of these two angles is created by this line. So we'd just say pretty much at this point, I'm just going to ignore this line, okay? But what I also notice is that they create this straight line right here. And since they create the straight line here, this blue one that I've drawn, then we can take the green angle and the orange angle, add them together like we see here, and then it would equal 180 degrees. Okay. From there you solve. But again, angles 1 and 2, maybe they're expressions like these. So you'd have to combine some like terms probably, and then use some principles of equality. I do not believe we're going to see distribution in this lesson or on the assignment. But I could be wrong. Okay, so principles of equality. Just going back to what principles of equality are telling us to do. They tell us whatever you do to one side of the equal sign, you must do to the other side of the equal sign. Okay, it's that easy. So if you add a number to one side, you got to add to the other side. Subtract, multiplication, and division as well. It's just, there's purposes for these. Okay, now these come after distribution and combining like terms in our solving equations strategies. Okay, so we use addition and subtraction specifically to make zeros. Why do we make zeros? So we can ignore the zeros. Okay, just like we do with people that are zeros. So we're going to ignore the numbers that are zeros too. Pretty much ignore them completely. They're there. We're just going to ignore it, okay? And then we got multiplication and division. These are to make ones. But again, it's not just that we're making any of the numbers ones. It's to make the coefficients one. And generally, we usually always make or use addition or subtraction to make zeros first when we're doing principles of equality, and then we will use multiplication or division to make coefficients ones. That comes second. Pretty much the last thing we do. Once we make the coefficient one, we're pretty much good from there. So all that stuff is review, and pretty much this is review too. It's just now we're expanding what the angles look like. That's it. Okay, so right here on this one, it says to solve for the value of x, find the value of x, but it does tell us up here lines N and M are parallel. Okay, that's good to know, because if we have one of the three special angle relationships, then we know that the two angles are the same, they're equal to each other. Okay, so let's identify them. I got this angle here, 7x minus 3, and this angle here, 6x plus 17. Is there a special angle relationship here? Well, They are at different intersections. That's a good start. I also know just for the parallel lines, they're on the outside of the parallel lines. Okay, so these are exterior. Are they alternating? Well, 7x minus 3 is on the right side of the transversal, whereas 6x plus 17 is on the left side. So that tells us that these two angles are alternate exterior angles. Which means that they are congruent. Okay, and again, congruent just means that they are the same, which means that I can take the two angles. So I got the 7x minus 3, and I also got 6x plus 17. Well, this means that since they are alternate exterior angles, I can put the equal sign between them, and then all I have to do now is use principles of equality to solve for x. I don't see any distribution necessary. I don't see any combining like terms. So, straight principles of equality right now. All right? Now, for me, I see the 7x first, so that means I would want to deal with the x's first. You don't have to. It's up to you. You can work with the constants. But I personally, I'm going to zero out the smaller of the x's. So I got 7x's here, 6x's there. 6x is smaller, so I'm going to actually zero that out by subtracting 6x's. Okay, it's just if I do it to one side, that's the principle of equality. I got to do it the other side, okay? Now notice I'm combining these negative 6x minus 6x's with the 7x, not minus 3, because they're not like terms. I can't even combine those. Well, what happens here? 7x's minus 6x's would be 1x's. I still got the negative 3 here, which I can drop. This would equal 6x minus 6x. That's 0x's. That zeroes out as planned. And I can drop my 17 right there, okay? All right, so this is my new equation that I need to solve. And I just want to isolate my x's, okay? So that means that negative 3, I got to zero that out as well. So we'll use principle of equality. And for this one, I would have to add 3 there. But again, it is a principle of equality, so if I do it to one side, I'm going to have to do it the other side as well. Add 3 there. This allows me to take my 1x and drop it, and that should equal, because negative 3 plus 3, that's going to zero out as well. 17 plus 3, boom, 20. Now, some of you, I think, noticed that the coefficient is 1, but if you didn't notice and then you're like, hey, I'm going to do another principle of equality, you could. Right? Because the last thing we would usually do is make that coefficient 1. So some students like to show this, right? Because usually at this point, if you're using this method, you always divide by the coefficient here, but it's still 1x. Okay, so it's just, I'm going to put an x equals 20 divided by 1. Anything divided by 1 is itself. And so x equals 20. But again, I think some of you guys would have noticed that back here and just made that green one a phantom one. It's still there, it's just you can't see it, okay? All right, now x equals 20 should be our solution. What is a solution? A solution is a value that makes the original equation true, meaning that these should actually be equal to each other, okay? If this is true, so we have a little bit of context now that it's great context, but it's some. This means if I replace this x with 20, then I should get the same exact angle measurement as if I replace this x with 20. Well, what happens? 7 times 20 is 140, minus 3, that makes this 137 degrees, okay? If I replace this x with 20, I should get exactly the same angle measurement. 6 times 20 is 120, plus 17, yeah, 137 degrees. So this checks off. Both angles, these alternate exterior angles, are exactly the same measurement because we replaced the x with 20. We didn't have to solve for the angles. I was just showing that you can, just to make sure that you do have the solution. The real value here that we need is just x equals 20, done. So here's one of our special cases right here. We can see that these two angles are at the same intersection, which means really this one is obsolete, and that lines N and M being parallel, that doesn't really matter to us, okay? Because again, these two angles, they're the same exact vertex or intersection. So I can ignore all the rest of this stuff. In fact, I don't really care that line T is a transversal because I just need these two lines. And yeah, this is line T. So what are my two angles? I got 6x minus 4, and I got 3x plus 4 right here, right? Well, what is the relationship here? Because they're already at the same intersection, so they cannot be alternate interior, they cannot be alternate exterior or corresponding. They can't be because they're at the same intersection right off the bat. But what I do notice is that these two angles make up this line N right here, which means that if I were to take these two angles, so I got 6x minus 4 in red, and then I got the 3x plus 4 in purple. This means that if I were to take these two angles, add them together, again, I should get that straight line N, which is 180 degrees. Straight lines always have a measurement of 180 degrees. Well, this just gives me an equation to solve, you guys. Right here, boom, just solve the equation. And yeah, right here I noticed right off the bat again, just from the equation that we've drawn out, that I have some like terms to combine. I have some x's to combine. 6 of the x's and 3 of the x's would be 9x's. And then I've got this -4 and +4 right there. It's just if I combine those, I get 0. So, and you can put the +0 right there. Yeah, this should still equal 180. Okay. It's just, we know that if you got +0, like I do here in orange, then I can just make it a phantom 0. It's still there. The +0 is still there. I just don't want to look at it, which is why we've been making some of the values zeros anyways. So what do I do at this point? Well, I got 9x equals 180. I don't want 9x's. What I really want out of this is 1x. How do you change 9 to a 1? Principles of equality by dividing it by itself. Okay, so 9 divided by 9 is 1x. 180 divided by 9, that'd be 20. And yeah, this is just one of those unique cases where both examples just x equals 20. But again, I'm going to skip that last step and just make it x equals 20. That should be good. Okay, well, what do we get out of these angles if I replace them with 20? Well, I'll start with the 6x minus 4, okay? So I'm going to replace this x here with 20. 6 times 20 is 120. Then minus 4 makes this 116 degrees. Now the purple angle is not going to be exactly the same as 116 degrees. What it should be is supplementary with this 116, meaning if I add the two together, I should get 180 degrees, right? Well, 3 times 20 is 60. Actually, I'm working in the purple angle. 3 times 20 is 60. Plus 4 would be 64. So this angle here should be 64 degrees. What happens if I add these together? Yeah, I get 180 degrees, which is what we planned because these two angles were supplementary. They create this straight line, and we're good. So yeah, that means that we found our solution. X equals 20 is our solution. That's the value that we did want. Good. I hope you guys are feeling pretty good about this stuff because we've seen it before. Just, I guess maybe the expressions may be a little bit bigger. All right, on this one, okay, so first off, these two angles, right? We got 7x minus 1, and then I got 8x minus 14 right here, okay? So we got the two angles. They are at different intersections, so I'm expecting to see one of the three special angle relationships, although that doesn't always happen, right? Well, the red angle here is on the exterior of the two parallel lines, whereas the purple angle here, 8x minus 14, is on the interior. It's on the sandwich between the two parallel lines. So they're not alternate exterior angles, and they're not alternate interior angles. So that leaves us with corresponding. Are they corresponding? Well, 7x minus 1 from this intersection is up and to the right. 8x minus 14 in purple is up and to the right. So they're in the same position of different intersections, which tells me that these two angles that we're looking at right here are corresponding angles. And again, the reason why that's important is because since they are corresponding angles, they're also congruent, which means they're the same. So that's like the same example we saw two examples ago, where those angles weren't they alternate exterior, or like the bell work where they were alternate interior angles. Okay, so these are corresponding angles. So let's take those two angles. Okay, I'll start with the red one. Again, I'd like to start with the top one, not that you have to. And I got 7x minus 1, right? It's my red angle. And I got the purple angle at 8x minus 14. Well, those two angles, since they are corresponding and the two lines are parallel, which it tells us at the top there, that means I set them equal to each other. Then I have an equation that I just got to solve. Okay. Now I got more x's on the right side, so generally I would subtract the 7x's right here, but I'm going to do this one a little different just to show what happens if whatever method you use. Okay. So I'm gonna zero out the 8x's on this one. Again, I'm just doing this a little differently. But you should get the same answer no matter what. Okay, so principle of equality, I'm gonna zero out the 8x's by subtracting 8x's. Just if I do it to one side, I gotta do the other side, okay? So 7x's minus 8x's would be 1x's. I take this -1 and drop it, which is going to equal 8x minus 8x is 0, but then I can drop my -14 there, okay? All right, so I got 1x minus 1 equals -14. My next principle of equality is going to get me pretty close. Oh, 7x minus 8x is, sorry, that's -1x. Yeah, don't forget that negative. But I want to zero out that -1 because I don't want the -1x to have anything added or subtracted to it. So I'm going to have to add 1 there. But the principle of equality says if you do it to one side, you got to do the other side. So add 1 to the other side also. Okay, so there's my equal sign. So I got my -1x, which I can drop. And I got -1 plus 1 here. That zeroes out as we planned. And then -14 plus 1 is -13. Now, if you get this, because some students from the previous classes were like, I got my 1 coefficient. No, you have a -1 coefficient, but it needs to be +1. So we do need to actually make that a +1, and that's not too bad because we can use a principle of equality to do that. Remember, to make ones, we have to use either multiplication or division. For this one, I'm going to use division. Okay, so anything divided by itself is 1x in this case. -1 divided by -1. It's just if I do it to one side, I got to do the other side as well. So -13 divided by -1 is +13. Okay, and yeah, I'll just make that a phantom 1 there, coefficient of x. Well, what happens if I replace the x's with 13? Well, I get the same value. I should. So I got 7 times 13 minus 1 on my calculator. Well, it says this one right here is 90 degrees. It doesn't look like 90 degrees, not that it has to. But if I replace the x with 8 times 13 minus 14, I get 90 also. Okay, so again, this proves just the fact that I checked there to make sure these two angles are the same degrees. That proves that x equals 13 actually is a solution. If you missed the objective, there it is. I can make and solve equations from special angle relationships and parallel lines. We did see that one example where we didn't care if the lines were parallel because the two angles were supplementary or made a straight angle. And you will see some of those on the assignment too. Okay, there's our objective.